Hi, Rick Lineker here. This presentation will teach you the basics of Internet security. This presentation is part of the SEC 110 course at Rockingham Community College. So we're going to start off talking about the Internet Protocol Architecture, or IP architecture. It is important because it standardizes communication between computers. Without this, different computers would have trouble talking to other different computers. And as a matter of fact, I can remember a time when there are lots of different communication protocols, such as Token Ring and so forth. And so this is a really good thing for computers so that everybody can talk to each other. Attacks attempt to take advantage of this standard, and it's a widely publicized standard, so there are no secrets. So these attacks make it operate outside of its specification. And it's also important to note that computing systems are composed of many building blocks. Therefore, there are lots of different ways to launch an attack, or different ways to find vulnerabilities. Many different building blocks mean there's much more complexity. And much more complexity means it's a lot harder to defend. So the communications architecture has a number of primitives that everything is built on. It's kind of like writing music. It's all built on a scale. Well, communications are all built on the following primitives. The first is a send primitive. One way or another, someone's got to send a piece of information or a data set of some sort from one endpoint to another. A confirm primitive is when someone may get a piece of data and it sends back confirmation that the data was received. A listen primitive might sound non-intuitive, but it's when a system is listening and possibly may answer. The receive primitive is when you actually heard that there's a message for you and you receive it and bring it in to wherever you happen to be. The status primitive is just checking to see what the status of the system is, or some communication, or whatever. So now let's get specific about some of this stuff. We have layers, and many of you in networking class learned about the 7-layer architecture, and what we're going to be talking about here is a simplification of that just a bit. The PHY layer covers all the physical parts of the network. The MAC layer covers the addressing. The network layer actually covers the IP addressing, how to get messages from one place to another. The transport layer essentially is kind of like the old session layer. It maintains sessions and sends out arbitrary amounts of data. And the sockets layer essentially is what we used to kind of call the application layer. It presents an API to any kind of application that wants to talk over the network. So these are all supported by a number of protocols: ARP, Address Resolution Protocol, DHCP, Dynamic Hosts, Configuration Protocol, DNS, Domain Naming Service, ICMP, Internet Control Message Protocol, and routing is what it is. So the PHY layer pretty much has to do with the actual hardware, such as the plugs and the jacks, and there's also a little chip called a UART that stands for Universal Asynchronous Receiver Transmitter. That's actually what converts the bytes to bits on the actual media. Data is converted to bits and transmitted over the media, and like I said, the UART actually does the conversion and sends it out as serial data. The MAC layer is the next layer up in the series. The PHY layer and the MAC layer are often called the PHY MAC layer. Sometimes together they're called the data link layer, and this is, if you remember the old 7-layer model, this is the same as the data link layer from that model. The job of the MAC layer is to send and receive frames. Really simple. It does give a header, and the header usually has some sort of addressing information, not the IP addressing, but the physical address. And then following the header is the data payload. Now a MAC address is guaranteed to be a unique number in the universe. Now that's an over-exaggeration, but at least here on the planet Earth, because IEEE manages MAC addresses and guarantees that they're unique. Now I've heard that they're going to create larger MAC addresses because they're starting to run out of them. So what they're going to call the new MAC addresses are Big Macs because they're bigger. The network layer essentially is media independent, so it relies on those two lower layers, and it manages forwarding data from one place to another. It normally contains the source and destination information in the form of IP addresses. Now IP addresses are not guaranteed to be unique. They usually are, but not necessarily. The transport layer creates and manages two-way communications, usually called connections, and we used to call this in the 7-layer model, if you remember that, the session layer. It supports delivery of messages of arbitrary length, so it breaks them up into smaller packets and sends those. IP datagrams can be lost, and this is the layer that detects and retransmits lost segments. Actually, on the receiving end, it also resequences them when it gets the lost packets. Okay, the sockets layer, it's a layer for application software to use. So if I write an application that wants to, say, communicate over the network or the internet, I will talk to the sockets layer, and the sockets layer will then in turn go down the pipe to do the communications. Okay, ARP is Address Resolution Protocol, and it resolves IP addresses to MAC addresses. Now I'm going to show you in just a minute. There's a utility that you can access from command prompt. Okay, so here I am at the command prompt, and if I just type ARP and then /?, it will tell me all the command line parameters that are available to me. Okay, so what we'll do is we'll type ARP-A and see what it gives me. So there we go. Got a bunch of IP addresses and their corresponding MAC addresses. Now I don't even know what my IP address is, so I say ipconfig, and I am .70. So by inference, it doesn't tell my own MAC address, but what this down here does. But anyway, I can tell the MAC addresses for all the remote things. And let's see, .69, I wonder what that is. You can actually do ping-a 192.168.1.69. It'll attempt to do a reverse lookup. I'm not sure if it will or not. Okay, so whatever 6BE6, I mean, that's what it kind of resolved to. I wonder what 71 will resolve to. It might actually be my router. Okay, it did not resolve .71. Okay, so that's the ARP utility. Okay, so DHCP is how many computers get an IP address. When a computer first starts up, it sends out a signal, essentially a broadcast signal. And if there happens to be a DHCP server that's within listening range, it hears the request, looks through its database to see which IP addresses are unassigned, and sends that IP address to the requesting host. Now, at the same time, it also remembers the MAC address of the requester, and so it keeps a list of IP addresses and their corresponding MAC addresses. All the other traffic on the network is also listening for this traffic and keeps their own. This is how they develop their ARP table. So DHCP, I can't really show you a demo of this, but anyway, take my word for it. It works. DNS, domain name resolution. Domain name resolutions are done through DNS. Essentially, DNS is kind of like the big white pages of the internet. You can type in a domain name and it will give you the IP address of that domain. Essentially, your computer doesn't use domain names to communicate over the internet. It uses an IP address. It's kind of like calling a phone number. You call a phone number, not an actual. You don't type the letters of the person you know. You type their actual phone number. So now I'm going to show you a real short demo of finding out DNS entries. So let's say it's really important that I find out the IP address of Google. I can just type in ping www.google.com and it will go and do a resolution through DNS and find that Google's IP address is 74.125.159.105. Now, how do I know where my computer is going to find this information? Well, most service providers give you a DNS server that is part of your configuration. And if I say that, ipconfig/all, it will show me somewhere in here what my DNS servers are. Let's see. Okay, it is not doing that because my router is actually functioning as my DNS server. So as you can see there, see where it says 192.168.1.254? Essentially my router is functioning as the kind of as a proxy DNS server. You can also get some pretty interesting information about domain names. Okay, I've got a sysinternals directory here. If I type who is ricklineker.com, it should come up and give me some information about that particular domain name. Here we go. Who owns it and so forth. Now, who is part of the sysinternal suite. It's not a command line program that ships with Windows or anything like that, but sysinternal suite is free, so I encourage you to download it and give it a try. Okay, so ICMP is a set of diagnostic messages, and I didn't tell you this, but Ping behind the scenes uses ICMP. What it does is it goes and well, first it does a DNS resolution, but then the second thing it does is it goes and kind of queries the state of another host. And so Ping is a really nice diagnostic utility just to find out if some host is alive. Traceroute is going to show you all the hops between your host and some other host. So let me give you a really short demo of Traceroute right now. Okay, so let's say I want to find out what path my packets are going to take to Yahoo. So I type traceroute www.yahoo.com and then I watch. And for every hop, which is every router that my data is hitting, it's going to show you where it is and the relative time it takes to access that particular hop. Okay, occasionally it'll get kind of stuck on these hops, and it doesn't always give you a domain name for the routers, but sometimes it does, and you can kind of get a good clue for where the router happens to be. These are all IP addresses, but sometimes when you do a trace route, you see a bunch of actual domain names. There's a domain name, att.net. So far we've taken 11 hops. This is our 11th just to get to Yahoo. There's Yahoo, or at least some of the Yahoo devices. So to get to the actual Yahoo server to retrieve data took us 16 hops. Pretty amazing.